I'm Bradley Tyree, and I'm a NASA test operations engineer here at the A1 Fred Hayes test stand. From a really young age, I was interested in space, and I can remember being in elementary school and doing like the solar system science projects and things like that. Also, my great-grandfather worked out here for Rocketdyne and Rockwell and Boeing as they changed names throughout the years from the 60s, 70s, and even into the early 80s. So he had a direct part that he played with the Space Shuttle main engine program. I have pictures of him working on the engine and working at B2, back when it was more just like a skeleton. And so that's really interesting, and that was really fun, growing up, hearing all these stories and seeing the pictures of him working on the old rocket engines and things like that. So I never thought I would see myself at Stennis Space Center, but as I came up and I started going to college and studying aerospace engineering, I realized, wow, I could follow in his footsteps, and do the same kind of work. Never pictured myself doing that, but so I've always been interested in it, and that's how I guess I found myself here. As a NASA test operations engineer, one of the roles that we have to perform is the role of the test conductor. And the test conductor is the vessel at which all of the operations on the stand has to be coordinated through for testing the rocket engine. So as a test conductor, this was never something that I saw myself doing whenever I first started at Stennis Space Center. I kind of remember sitting in the back of the room and thinking, wow, that person up there is important. So as the test conductor, you're responsible for dozens and dozens of different technicians and engineers, operations. They are all counting on you to know what's happening on the stand at all times. You're responsible for knowing the valve positions from level 1 to level 10 and what systems are pressurized and what systems aren't. And people are looking to you to tell them when and where they can perform their job. And so there's a lot of responsibility and there's a lot of pressure on the test conductor. Sometimes you're having 5 or 6 conversations at one time with 5 or 6 different people simultaneously. So it can be stressful, but it's also very exciting. On a typical test day, the test team arrives at the control center around 5 a.m. So we start preparing the facility for calibration, right? We have to make sure everything is reading accurately and precisely, because we're going to be reading all of this data back and conveying it and sending it out and processing it. We have a lot of analysis that happens. So the team arrives and everybody starts getting on station. We have transfer engineers for the different propellants that goes to the rocket engine. We have data engineers, video engineers, technicians start getting on station on the test stand. Everybody starts falling into place. That's all day long, 12 plus hours, right? You're in the chair and you're coordinating all these different activities, and you have all these different conversations happening. You have all these systems you have to monitor and data you have to watch. All these things are happening, and test day is this just giant adrenaline rush, right? So you're building up and you've got all these operations, and then 1 o'clock, 2 o'clock happens, and here it comes. You're getting ready to hit that button to start that engine. It's like being at the top of the roller coaster, right? You're right there at the peak and you're ready to hit the button. You hit the button and that rocket engine starts firing. Now you're on the roller coaster and you're just holding on, right? You're watching all these different data systems. You're watching temperatures and pressures, and all of these things are happening, in that 500 seconds. One of the more important things about being a test conductor is how the team is integrated into that role, right? So the test conductor's job can be much easier if we've got a really knowledgeable, trained test team, right? And so everybody can take their specific individual systems and relay that information to the test conductor, and the test goes smoothly when you're getting lots of thumbs up from the test team, right? It helps to have a team that's on their game all the time. Today we'll be testing the RS-25 engine, which is used to power the Space Launch System on the Artemis missions. These RS-25 engines are Space Shuttle main engines that have gotten new upgraded parts. We've used things like 3D printing. We've got different manufacturing techniques. And so we're testing these engines as part of a certification series right now. And this series will prove and provide data useful for future Artemis missions and future rocket. Engines. Here at NASA, we talk about testing like you fly, and a typical RS-25 test runs for about 500 seconds, because 500 seconds is about how long it takes for the Space Launch System from the ground to reach orbit. So You might think, why is this test going so long sometimes? And that's because we're testing like we fly. We want to make sure that we hit all of the same parameters that we would need to hit in a launch day situation. During today's engine test, you'll notice the rocket engine gimbal, or in other words, it'll pivot around a central point, right? This gimbaling is used during flight to control and to stabilize the rocket as it reaches orbit. We want to use the gimbaling to control the trajectory of the rocket as it reaches orbit. During the test, we'll take this gimbaling and we'll take it as far as it can go, right, to simulate any kind of conditions it might experience during a flight. One of the cool things about the rocket engine test that most people don't know about is that we actually take the rocket engine past its limits, past any parameters that it might see during a flight, right? We take it to a higher power level, to higher pressures, and we gimbal this engine to higher angles of attack than it would probably see during a launch, during a flight situation. And that's because, if I was an astronaut on board this rocket ship, I would want to know that this thing's been tested to its absolute limits, right? It needs to be able to perform more than it's designed for. And so that's the whole point of us doing these rocket engine tests. The RS-25 engine uses liquid oxygen and liquid hydrogen as the propellants for the engine. We use liquid hydrogen because liquid hydrogen has the highest specific impulse or efficiency of any other substance. It's extremely hazardous and it's extremely hard to control. Liquid hydrogen has to be at temperatures more than minus 420 Fahrenheit. So it's a hard to handle propellant, but you get the most bang for your buck out of liquid hydrogen. And I think that's what we'll continue to use on all of these heavy lift space systems. As you're watching today's test, you'll probably notice this great white plume exiting from the rocket engine exhaust, right? And there's a myth that this plume is smoke. It's actually water vapor. So the two propellants that we use in the rocket engine are made up of liquid oxygen and liquid hydrogen, which forms H2O. So you've got this extremely hot exhaust gas coming from the rocket engine, right? Thousands of degrees. Meanwhile, we're pumping thousands and thousands of gallons of water at the rocket engine exhaust to help cool the structure as the exhaust is being directed through the deflector and then out. The atmosphere in the test control center on test day is very relaxed at first, right? Everybody's coming in, they got their cups of coffee, everybody's getting on station, and we're starting to monitor data. Well, as we bring up systems, you can kind of feel the tension build in the room, right? It slowly gets quieter and quieter as you approach that launch or that engine start button. So as we're going, we're building up, the tension's getting thicker almost, you can feel it in the room. And then I would say that 30 minutes before you start the engine, it's very quiet in here, right? And a lot of things are happening. We have a lot of operations that have to happen in those final 30, 15, 6, 1 minute call outs that we have in our test countdown. Test day, there's nothing like test day, right? And of course there's all the time and work that goes into test day, but there's nothing like test day. It doesn't feel like work at all. It's very fun. It's exciting, it's challenging. It's dynamic, right? A lot of things are happening all at once, and I would say that's true for anyone in the control room, anyone involved with test. I don't think it's just test conductor. Your transfer engineers, your instrumentation engineers, I'd like to think that they're also feeling that feeling, right? It's like, doesn't feel like work. I'd say we have probably the coolest job. Some advice I have to maybe, some of the younger generation that's getting interested in some of this work and thinks, man, I'd like to do that someday. My advice would be to don't sell yourself short. Don't think that you can't. If I was to meet myself 10 years ago, there's no chance that 10 years ago me would have thought I'd be where I am today. So I'd say my biggest piece of advice is just don't stop, don't give up, right? Keep learning, keep trying. You can do it. If I can do it, anyone can do it. That's my advice.